So, as you might know, this series of React workshops have been centered around React and Redux. Specifically, we have had a couple of sessions about Redux and Redux, different types of Redux middlewares. So, but right now, in this session, instead of working on Redux, what I'm going to do, I'm going to just talk about more, I'm going to try to cover the benefits of server-side rendering and the reason that we need it, and also what is the difference between the old-fashioned single-page applications that we used to create using Angular 1 or Backbone or other MVC frameworks in compare with what we can create using React. And the important part of it is that we have already covered parts of these topics separately in different sessions. For instance, when it comes to server-side rendering, the first thing that we should notice here, I'm going to show you pieces of code, different applications that we have created during this series of React workshops. This apps directory that you can see here have almost all of these different live coding experiences that we have had during this workshops. So user management app is the one that I created specifically for this workshop, and it works. You can clone the GitHub repository and run the application, and it has server-side rendering. And let me just show you. Inside this src directory, you can find that there is a server.js. So the server part, the whole application is actually a Node.js application. But the Node.js part is the only reason that we need the Node.js here is for server-side rendering. So the technology stack is like React in the browser and JavaScript in browser and React on the server and Node.js on the server. So now for the server, for users to be able to see any websites, we should be able to run an HTTP server, and to do so in the server.js file you could find this Express application. So if you scroll down inside this code, you're going to see this wildcard here. This is the server-side rendering middleware. As you can see, the comment here. And if you go through the steps that we have taken in this code, you can see that the first step, again, the usual steps that we should take whenever we want to render a React application inside the browser. Here we are doing it inside a Node.js middleware. So the first thing is to configure the store. And then there's this runtime variable, the initial now moment to be dispatched. And we set up the context. And we are going to cover these variables and talk about them more as we go on, but I just want to give you the big picture here. So, and at this point in line number 105, we resolve the routes. So as you can see here, this star sign means whatever URL that is hit after your, let's say if it is localhost / whatever you put after that is going to end up here. So now you are in charge, and what you could do, what we are doing here, is to pass the information that we need to the universal router, which is the router that I'm using here instead of React router, to resolve the current route. And the information that I need to pass is simply just request.path and also the query. And now I have the routes and almost done right here. And at this point, I send back the HTML content of my page. So as you can see here, I have this render to static markup. And this is how the server-side rendering part works. Now, let's just go through the similar steps that we take here in client.js. Okay, there is no express.js here because whatever code that you put here happens, runs inside the browser. So here, the first thing that we need is the context. We set up the context. We set up the store right here. If you want to, you could just, if you want to make it more similar to what you just saw in the server.js, you could just create the store variable like this. And then right here and use it. So the first step is to set up the store. Let's see what happens in server.js. Here, the first step is to configure the store. Again, configure store. Let's see what is this configure store. This configure store is something that comes from store/configure store. And right here we have it, configure store.js, which means this piece of code is universal. We have already covered the term, the topic, universal JavaScript and universal React, but just to give you some hints, I would say that when we say this code is universal, or this is a universal JavaScript code, it means that it is environment agnostic. It's going to work on any JavaScript environments. And at this point, we have two different environments, one inside the browser and the other one inside the Node.js. So this configure store.js module, which has this configure store function, should be environment agnostic, should work the same, should have the same behavior on both sides, inside the browser and on the server. And you can see how it actually works. So this create helpers function is for using Redux Thunk, which is one of the greatest Redux middleware that I have used, and not the greatest actually, but one of the greatest. So, and here you can set up all your Redux middlewares, but as you go on, this dev is for the development environment. When you run this, Redux Thunk, yeah, Redux Thunk. Here, do you see this? And line number 22, and in line number 2, you can find the imports. Great. So, and if you are interested, you can find other episodes of this React workshops. In what we have done in those episodes, we have configured different Redux middlewares specifically for this one single application. And interestingly enough, all of these Redux middlewares could work all together without any issues. So as you can see in line number 21, I have this commented out piece of code, Saga middleware. This is for Redux Sagas. And this part, before middleware and after before logging middleware, after logger middleware, is something that I showed how to create a Redux middleware And this epic middleware in line number 20 is actually this Redux observable middleware. You can find it right here in line number 4. So at the end of the session, if you want to, I could walk you through the different steps that you could take to set up different, how to use these middlewares and how to take advantage of them. But for now, let's focus on the server-side rendering part. So if you scroll down this code, you can see all these variables, everything could happen on both sides. Which means now, inside this client.js, whenever we call this configure store function, that specific function is going to be called. But there is one quick difference. As you can see in server.js, the variable that I pass, so let's first get back to the configure store.js function here. So the first argument that we can pass to this configure store function is the initial state. In server.js, let's see what we have passed. Since on the server we don't actually have any specific states other than the user information, if there is any information. For instance, if you use JWT and if the request is authenticated using JWT, the practice works like this, that we usually have this user object attached to the request object. That's now how you can put, how you can add this user object to your initial state so that you could use it inside your Redux models. So, but if we go back to the client.js, there is nothing like user or any other object like that here. What we have here instead is a global object called app state. This is the most interesting part about the way that we can set up React/Redux applications, and the way that React and Redux could help us set up a server-side rendering part really, with the most, with the best way possible. It's it's really smart because you can render all of your components on the server and set up the state object, and at the end, what you do, you create this state object as the global state object, and you can pass it right through your HTML string, and I'm going to show you as we go on. So anyway, this app state is something that we should cover later, and it is one of the important part of this topic. So the first step was to set up the store. Here we have this patch part, which is, you can just remove it, or if you benefit from this variable initial now, that could help you log, have it, have more information about, the different types of requests coming to your server, and this could help you to log those information, the moment that request comes through your server. So now, and here, this CSS variable, the next step, is something that I'm using here, and this is part of the boilerplate that I use for isomorphic CSS, isomorphic style loader. And the way that it works is, the practice is part of this this specific package. If you are interested, we could cover that as well. But the important part of it is that there is a huge difference. Without isomorphic style loader, the way that we usually used CSS and Sass or less or whatever CSS compiler that you use was like this. We wrote the code, CSS code, and we probably put it right next to our component, or we might have some kind of style directory to put all of the style codes in it, and at the end, using Gulp, Webpack, or Grunt, or one of these build workflows, we could bundle all of the CSS codes that we had written inside one single CSS file or different CSS files, and all we had to do then was to add those CSS files as link tags inside our application. But isomorphic style loader doesn't work like that. It is something that I really like, but it has its own trade-offs. For instance, the most important part of its trade-off is that it adds all the style codes right inside the page using a style tag. And again, it's another topic that I'm going to show you later, right after we finished covering all these steps. So we should create this context variable, but this insert CSS function again is part of the boilerplate that we should use to implement isomorphic style loader, and we should pass a store as the variable. As you can see, this part is quite similar to what we have here. So context, insert CSS, store, server.js, context, insert CSS, store. So here now is the next step. Universal router.resolve, and in client.js here, let's just see, we create an asynchronous function, and instead of resolving it like that, this part is for on location change. So now the reason that the way that the client.js works for the next step differs from what we just saw in server.js is that whenever this piece of code is running right here in line number 105, it means that a new request has come into this middleware. Which means again, this request could be a redirect, or could be a reload, or could be a new page being opened inside a browser, or sometimes even an image that you have in one of your you have used inside one of your components. So the request, because this is a wildcard, the request again comes here. So what you can do here, you can just resolve the route. You don't have to listen to any changes, because when you are here, the change has been already has been already made. So when you are here, it means that URL has changed and some kind of URL change has happened. But in client.js, once we write here, we create the context, now we should listen with some kind of scenario. We should listen to the location change, and for that we use the history API, which is a great feature of HTML5 history API. So you could find a link, you could find more information here. So this is the history API. You can install it like this. You can use it, and you can create the history object, and it's really, you know, cool, and I really like it because so you can redirect the user from one page to another page without reloading the whole page. So to be able to do that, for instance, to be able to reroute a user from page A to page B in a single page application, we used to use this hash signs. So, you know, if let's say the host name slash and sharp home, that means that you want to go to the home page. And if you want to redirect your user from, you know, reroute your user from clients without reloading the page, you should just change the URL and or assign another hash. But which again, this part was not consistent with the way that server routes worked. But this HTML5 history API is one of the greatest features that is allowing us to set up the server-side rendering process much easier. So one of the functionalities that it has is that we could listen to any changes. We could listen to any location changes like this. So let's see what happens right here. So as you can see, the other thing that you should notice here, not only have we added this on location change function to this listen history.listen, we have also called it right here, because this when this client.js file is loaded, it means that the page has been loaded, and initially the current location actually is the new location, and actually the first route is actually the first location change. That's why we should call it. So let's see, which means right after creating this context variable, the next step actually goes into this onLocation change function. So this part is for you to, if you want to keep track of your scroll position in the page. After reloading the page, you can use this one, this code. So, okay, current location equals location, which comes as the first argument of onLocation change function, and here we go. This is actually again the next step after creating the context variable. Route equals await universal router.resolve, which is again exactly the same thing that we have right here. So as you can see on the server, since we have this Express.js middleware, we don't have to listen to any redirect changes because we are already inside that redirect change. But here, after setting up the variable, we listen to the change and we call that function for the initial call, and this is where it goes. Now you have resolved the routes. So there is this piece that you can find on both sides, and again this means that you can, if you want to create a route, a conditional redirect inside your route, this is how you can do this. You should create a route and you can add this redirect flag to the route object. So here is the part that differs, the main important part. Inside our server.js, after we resolve the route, we create a function, variable called data, and then we pass a couple of information, like one of which is children. React DOM that render to string, and as you can see, it's, again, it's just a piece of string. there is no DOM here, which is exactly why we should pass a string. So we are not inside a browser, we are on the server, and what we need is the HTML string of the page. We just, as you can see here, we have resolved the route. This is where we can render at the end. This is where we can render the components. The huge difference that we have here between this piece of code that we have and this piece that we have here is that when you render your component this way, React DOM.render, this app components actually gets mounted inside the browser, which means the whole life cycle of the React component is going to be completed. You know, the first step is the constructor, and then component will mount, and then component did mount, and then render, and after that component did mount. But on this part, the render function of your React component is going to be called, but component did mount never gets called. Component will mount is going to be called right here. If you have any component inside this tree of components, the first being app, the other is the component that you pass to the route, and all its children, and you can go like this step by step into all of the other components that you have passed to your components. All of them are going to be rendered without being mounted, and the reason for that is all of it happens inside Node.js environment and not inside a browser, and the reason being we only need the string. We only need this this HTML string of the page. But now this again is another part of the whole server-side rendering part, the way that we have handled that. So let's just skip this variable style and scripts. So as you can see, this is store. As we all know, store has a function called getState, and whenever we call that getState, it's going to give us the state, the global state object, the global Redux state object. So as you can see, state object is just attached as an attribute to the date to this variable that we have, data. Now, excuse me, can you hold on? I will be back in a second. Okay, I'm back. Okay, so as I just said, store has a getState function, and we call it, and we attach that state, that global state object, Redux global state object, to this data. And at the end, let's see what happens. We have another render to a string, but this one is not just render to a string function. What we do here, we call a render to a static markup, and we pass it another React component called HTML. And this is the part that I really like about this way of handling server-side rendering. Let's see where this HTML comes from. So here, HTML is a component inside the components directory. Here we go. And this HTML, as you can see, is what we have instead of the usual index.html file that we usually have. in a web application. Instead of creating index.html file, what we have created is HTML.js component, and that this component receives some information like title, description, style, scripts, state, and children. So you can guess what this title is used for, but description also you can guess. But this state variable is one of the most important ones. If the state is one of the variables passed to this HTML component, this script tag is going to be rendered inside our server-side rendered page. Let's see what we have here. Dangerously set inner HTML. Here we go, app state. So what we have here, we have the serialize function. We pass it this state variable, and if you remember, we just discussed that state right here. This is the state variable. This line of code happens on the server, gets the whole object, it gets passed to this component on the server, and it's being serialized to a JSON. It's similar to calling JSON.stringify, and the return value is going to be like right inside our HTML page as a script tag, and adding a global variable called app state. And this global variable is exactly the variable that we use inside this client.js, where this point, the point that we call configure store, right here in line number 23. This app state, this piece of code happens inside the browser, which means the HTML has been already rendered on the server, and this app state variable is inside the page. So that's how we pass the state object from the server to the client. And that's how the whole thing actually works. The only difference between server-side rendering and client-side rendering here between these two is that using React is that on the server we don't mount the components, but on the client, after rendering everything, components is going to be mounted. We have the initial rendered HTML already, and we have the app state, and once a component is rendered, client is going to take over the rest of the process. So if for instance, if user clicks on something and you redirect the user from page A to page B, from that point, client is in charge of redirecting the user from page A to page B, which means the server code is not going to be involved anymore. But if at any point your user again clicks on reload button or hits the F5 button, the whole thing again happens. Let's say you load the home page. Let's just do this. Let's do this right. Let's see how now this works. Okay, at the end, the piece that I wanted to show you is this HTML. Just a string that we have here. We pass it 200 as a status code, and we send back the HTML. This is exactly rendering the index.html instead of creating the index.html as a file. Now let's run the code. cd apps user management app, and let's just hit npm start. And we need MongoDB to be started, and then we can just run npm start. Okay, what happens here is that we are using a webpack here to bundle the whole application. Here we go. Yeah, and that's the application that I was talking about. Let's see. Again, this is the home page. Let's see what we have here. Let's just call view page source. As you can see, there are some CSS codes right inside the page. This is what I was talking about when I said isomorphic style loader is different, because it adds all the CSS code right inside your HTML. Okay, you might say it's not a good practice, but again, it's a trade-off that you can think about, and you can consider using it or not using it. Specifically for the type of application that I am in charge of creating them and developing them. For instance, the e-commerce based applications, websites with high number of users, and this kind of websites that I really need the website to be user friendly, and I really need the website to be as fast as possible in terms of rendering something for the user. This way of handling styles and adding the CSS code right inside the page works better. So there is no delay between rendering the HTML and rendering the CSS code, since I have seen it a lot that you have the HTML parts and then CSS comes after that, because it is another Java CSS file and which should be downloaded, and your page doesn't have any CSS, and to avoid that you should add your CSS to the head tag, and then if you do that for the time that you have the CSS and the downloading process of that CSS file, the whole rendering process is going to be paused. But instead of all of it, I have just added the CSS code to my HTML using isomorphic style loader. Anyway, so let's just go to the end. So right here I have this variable app state. This is script tag which has the initial now, which handles groups, and if you just take a quick look inside of this, you can see this groups has data, lists, ID, name, administrators, users array is empty, another group name, testers. As you can see, there is no data here. There are 4 users in this system. There are 2 groups in this system. So let's just, now what I'm going to do here, I assume you all know what it means when we say single page application, but let's just see what is the difference. If I click here on groups page, what happens is that page is not going to be reloaded, although this groups has been added to the URL. The URL has changed without reloading the page. So let's just click on back. Here we go. We are here. Even the title of the page has changed. But let's just, to make sure, let's just do this. Let's create a variable inside the JavaScript memory. Hello, my var, and call us console.log once before sorry for this. Here we go. Hello, my wall. So now let's click on this groups and go to the groups page. We are gonna still have the same variable inside the JavaScript memory. The reason is being that this is a single page application and the whole page did not get reloaded. So whatever you have inside the JavaScript memory is going to be right here even after redirect change. So, but yeah, that's true. My home page, the source, the server-side rendered part has not changed. If you just click on the view page source, you're going to see the same exact thing, although it's not the current HTML DOM inside this page. But the page, as you can see, is like this. Now, if I click on F5, this is one of those, issues that we've had for a really long time, losing the states when we have client-side routing versus server-side routing. But using this solution, because router resolves the route on both sides, and server and on the client, if I click on reload button, my page is going to be rendered exactly the same. You can see this right here. But now if I click on view page source, the HTML, the rendered HTML is going to be different. Now I'm going to have a table tag here which has the grid information that I have had. So if I go back to the home page and reload, on this page, view page source, there is no table tag. As you can see, the reason that there is no table tag is that I have not used any table tag in the components of my home page. So if I click on F5 in groups page, I'm gonna see the groups page rendered using server-side rendering. And that's it. So this is the whole story. We have this server-side, for you to be able to set up server-side rendering, all you should do is just to add this Node.js, Express.js rendering middleware right here, similar, and you can implement it, without or with all of these steps that I have taken here. And also the same for this client.js. The whole concept is exactly the same. You can use another router, you can use whatever router that you want to use, but the whole concept that we have here is exactly the same. You should listen to the on location change. You can do this using history API, using any API that you prefer to use, but the concept is exactly the same. So now we have covered, I guess, all of it. Let's just get back to the code one more time. I promised that we're gonna cover more of these variables. Exactly. So history API is the key for this great feature that we have. For the end user part, nothing differs. So end user sees the URL change, but without seeing that blank page when we actually reload the whole page to be able to redirect the page. But using a history API and React and these great routers, that we can use along with React, user just can switch from page A to page B without any downtime, without any delay, without any gap. Just you can simply switch as though it is a mobile application, or sometimes even faster. Okay, so if you want to learn how to set up isomorphic style loader, the initial, the key part is that this CSS variable is something that is being stored inside the JavaScript memory, and this insert CSS function is being called whenever a component is rendered. So, but the other thing that you should do is that inside your components, when you create your component, you should create the CSS file of that component like this next to your component, and instead of exporting the component itself after you create that, you should wrap that component inside something like this. This with style is a function that isomorphic style loader gives us, and all we have to do is just to call that function. The argument that we should pass is the imported CSS or Sass file that we have here, and then this is the interesting part. This is a exactly the decorator pattern. So here, what it does, it returns another function, and you should pass the actual class, the actual component to that function, and that function at the end is going to return something that, and you can export that instead of exporting your component. So using with a style, using isomorphic style loader, what you should do is do this instead of doing let's just say here exports default. Instead of doing this, you should just create the class without exporting it, and then export this piece of code. If you want to understand how this works, you could read this code, but this part is quite some kind of boilerplate. All you should do is just to copy and paste this with a style file and pass it the CSS code that you have created for that specific component. And now, whenever this is something like adding your CSS code to the JavaScript memory. What it does, it doesn't add all of the CSS code inside the page. If the component is rendered, then that CSS is going to be added to the page. If you don't render as any specific component, the CSS code wouldn't be inside your CSS code inside your page, which is a really great feature that I really like, because in a really huge application, if we use the old-fashioned way of bundling all the CSS code, we always have this huge unused part of our CSS code. But using this solution, we are reducing the size of the unused part of our CSS codes. So yeah, this was one of the concepts, the topics that I had promised you to cover. The other one that we have already covered was the state object, the way that we can use it. And if you are interested, the server.js, you can find the most the latest updated version of this whole skeleton in React Starter Kit. React Starter Kit is the one great boilerplate that I usually use whenever I want to set up a new React/Redux application, and I have never had any issues using it because it already has the most important and most serious best practices that I usually need in a real world JavaScript application. Okay, that's it for this session. I hope you enjoyed, and if you don't have any specific questions, I'm gonna wrap this up. Yeah, the code, you can find this code online, and let me send you the link. I have this on GitHub, github.com/JSmentor/React workshops. So this is a GitHub repository. So this is a link. The other thing that I guess is going to help you is my YouTube channel. I have added all of the previous sessions. I have uploaded all of the previous sessions into my YouTube channel, JavaScript Mentor, and you can watch all of it, and you can subscribe to the channel if you